NRC. Welcome to IIChE NRC Foundation Day function, wherein we have invited a speaker, prominent speaker, Dr. Siddharth Singh, who will be giving a presentation. Before that, I request Dr. Chairman of NRC to say welcome address. We can start the proceeding after that.
Okay, thank you, Luthra Saab, and very good morning to all my fellow chemical engineers. Good morning to a very chilly morning in the northern India. Those who are in somewhere else may be enjoying better weather. So we are have organized this program as a foundation day for Northern Region chapter of Indian Institute of Chemical Engineers. As the records show, the chapter was officially established and recognized in December 1960, and there is no particular day for defined as a foundation day. But this chapter's recognition was approved on 12 December 1960's council meeting. But normally we celebrate it in January. So today's program, as Mr. Luthra has already mentioned, we have invited from International Energy Agency, Mr. Siddharth Singh, for a presentation. And we will also have the announcements for the award scholarships, which Professor Sami will do as chairman of the scholarship committee after the lecture. First, the lecture for today by Mr. Siddharth Singh, and I will introduce him, give his brief introduction. Siddharth Singh is a lead analyst and coordinator for the International Energy Agency, IEA. And incidentally, India is also associate member of IEA. He specializes in range of energy transition issues, in particular related to mobility, urbanization, natural gas, and of course, governance and regulations. He is co-lead author of the India Energy Outlook 2021, which is IEA's study on the future of India's energy economy. Previously has been German Chancellor Fellow, where he is specialized in Germany's energy transition at the Wuppertal Institute in Berlin. He has also worked at Nansen Institute in Oslo, Norway, and TERI in New Delhi. He is the author of Great Smog of India, which was published in 2018, a book on India's pollution crisis. Today, he will speak to us on building a net zero future, the outlook for energy and emissions in India. Mr. Siddharth Singh, please, floor is yours. Thank you.
Good morning to everyone, and thank you very much, sir. Thank you to the chairman, sir, to everyone else and all the distinguished guests as well as participants in this event. It's truly an honor for me to be with you today. Although I'm not a chemical engineer or an engineer, but I work with a brilliant team of experts from different professions and different expertise. So hopefully all this work that we have done together, I can summarize some parts and some aspects of it to you. So if I have everyone's permission, I'm going to quickly share my presentation so that all of you have it on your screens. I think it would have appeared on your screen now, if I'm not mistaken. Sir, can you please confirm if you can see the presentation?
It's on the screen. Okay, fine.
Perfect. Thank you, sir. Thank you. So, firstly, as I said, thanks very much. It's truly an honor. I think the IIA has been engaging in India for quite some time. But having said that, our engagement is largely with the government. So I thought I'll first quickly take about a minute to just very quickly introduce the International Energy Agency to those who may not be fully aware of our background and the work that we do. So the International Energy Agency was founded in 1974 in the aftermath of the oil crisis. That is, there was a conflict in the Middle East, a war in the Middle East, which eventually led to oil-producing nations boycotting some of the industrialized nations which were consumers of oil. So there was a major oil disruption and supply crisis for a majority of the industrialized nations of the world. So they got together and decided that we cannot let this happen again. So they created the International Energy Agency as a way to provide energy security to the world. Now, of course, that was a very different time. Back then, oil-related issues were among the key energy issues globally. Of course, today, the world has changed and the priorities of the international energy has also evolved in this new landscape. So now the International Energy Agency also looks at beyond oil, looks at other fossil fuels, looks at all technologies, including renewables, including nuclear, including hydropower. It looks at the affordability issues. It looks at taxation. So the understanding of what the world's energy problems are has also evolved in these years. And most importantly, and most recently, it has factored in the role that energy plays in contributing to climate change. So as a result, we have been working dedicatedly to figure out or to find out the ways out of this current situation where we are adding billions of tons of carbon dioxide emissions and other greenhouse gas emissions to the atmosphere, contributing to climate change. So that's how our priorities have evolved over the past several years. Today, as Sir has mentioned that India is an association member country, it's true. We have about 40 countries in the family, including full member and association member. So all these countries, contribute to over 70–80% of the global energy demand. So although the countries are fewer, but in terms of the energy economy, it accounts for most of the energy consumed in the world. With India, beyond the association membership, we also have a strategic partnership. So if we are working actively to enhance the relationship between India and the International Energy Agency, to the extent that perhaps someday this could lead to the pathway where India eventually becomes a full member of the IEA. So that's a work in progress. Sometimes at the international stage, these things take time. So we are working with the Indian government on this. And finally, one of the important things that the International Energy Agency does, and this is something that perhaps did not exist to this extent before the IEA was created in the 1970s, is that IEA aggregates global energy data and then uses that to make projections into the future, to understand what the future looks like. So our key publication annually is the World Energy Outlook. And apart from the World Energy Outlook, we come up with specialized publications. For example, the India Energy Outlook, which is a publication I will be speaking more about today. A very important thing to remember here is that the IEA does not predict the future, because nobody can really predict the future. We all make guesses. So what instead is happening is we're looking at scenarios and not forecasts. So whatever I talk about, about future numbers henceforth, is not something that we are saying that will 100% happen. What we're saying is, if we make certain choices today, if we put in place certain policies, and if we make certain types of investments, then all of that together could lead us to a certain pathway, and that pathway is the scenario that we're considering. So we actually have several pathways that we consider. The first one is the stated policy scenario. So the stated policy scenario is the pathway that we're currently on. That's the pathway which is a resultant of today's policies that already exist. On the other hand, there is a sustainable development pathway or scenario, which is the net zero scenario. So net zero in India's case is still an ambition. It's not something that is already translated into policies or investments. It's something that the Prime Minister announced recently, but it will take time for this to pass down into actual policies that individual ministries start pursuing. So with that, I would like to straight away get into the heart of the matter. As all of you would be aware here, the Prime Minister very recently, just about 5 to 6 weeks ago, announced in Glasgow at the Climate Change Summit that India will pursue net zero emissions by 2070. So what does that mean? That basically means that by 2070, the amount of emissions, carbon dioxide and greenhouse gas emissions that India will emit to the atmosphere will be about the same that we are able to extract from the atmosphere to ensure that it is about zero. That is the balance is maintained, on the planet. That would ensure that the carbon dioxide concentration in the atmosphere, which has been increasing since the industrial ages, that stops happening, and we are able to restrict global warming to less than 2 degrees, preferably 1.5 degrees Celsius, which is also bad because ideally we should not be seeing any major temperature changes. But this is still better than the previous situation where we were headed into absolute climate chaos over the next several decades. So this is a very profoundly significant ambition, because as you can see on the screen right now, but even if you, for some reason, if you're unable to see the screen, I'll still describe it to you. This net zero ambition is not merely an energy policy. It is actually fundamentally an economic policy. It changes the way we do business. It changes the way we live our lives. It changes all aspects of the way the society functions. Today, most of the emissions come from the power sector, specifically coal-fired power plants. So if you're talking about a net zero future, it would mean that the structure of power generation, the country will have to be completely transformed away from coal towards renewables, towards other form of low carbon technologies. Similarly, in the case of industries, most of the emissions come from either iron and steel or cement manufacturing production. Now you can imagine, to change something like that, you will have to fundamentally change the technologies itself, which lead to the manufacturing and production of this. Similarly, in the case of transport, most emissions come from cars, trucks. To change the way we travel is a major challenge. It would mean that perhaps someday in the future, you will not be sitting in your car and going somewhere. We'll have to rely more and more on public transport. Or maybe if you do have a car, that car would be electric. And perhaps the electricity that feeds into it will come from renewable sources as opposed to coal-fired power plants. Similarly, in the case of buildings, unfortunately, Indian homes are not very well insulated. We don't have energy efficiency. So the homes of the future could look very different to the homes that exist today. So for these and several other reasons, we say that this net zero ambition by the Prime Minister, by the Indian government, is a very transformative ambition. But it is to be kept in mind that at the moment, it is only an ambition. It is not yet policy. We are still waiting for various ministries and various other regulators to put in place mechanisms and rules and regulations that would transform this into an actual policy that India pursues sometime in the future. So while we saw how the world, how India's economy itself would change, what would this have and how would this have an impact at the global level? So here we see these are global CO2 emissions. So this is how much the world, all countries combined, emit annually, year after year, into the atmosphere. So as of today, about 35 billion tons of CO2 are emitted into the atmosphere year after year. And this has been increasing steadily since the dawn of the industrial ages. Before the Paris Agreement came into place, right? Before the Paris Agreement came into place in 2015, the policies that were in existence at that point of time would have ensured that emissions continue to rise to exceed 50 billion tons per year by 2050. That would have led to uncontrollable climate change. Perhaps we would have exceeded 3 degrees or more, which would have led to vast amounts of devastation in terms of either droughts or floods or extreme cold conditions, or extreme rains and hurricanes. So to avoid that situation, Paris Agreement put in place certain ambitions which translated into policies, due to which, as you can see here, we are at the stated policies, which are the policies, like I said, that are already in place today. These are the policies that either are already in place or the ones that are about to be implemented anytime soon. So all of that combined has ensured that emission actually remain flat over time. In other words, thanks to the Paris Agreement and the policies that have resulted as in the aftermath of it, we have ensured that by 2050, CO2 emissions are restricted to less than 35 billion tons from the 50. So we have actually done a great job already. But then that's not the end of time, right? So we have to keep every year after year, we have to keep enhancing our ambitions to change the world. We do that. Glasgow summit came about. So Glasgow Climate Change Summit happened in December. So before that, a lot of countries around the world, including China, including US, including all the countries in European Union and various other major economies, came forward and announced net zero targets. That is, they also said that by the year 2050 or 2045 or 2055, so around the 2050 mark, they will pursue net zero emissions, which meant that thanks to these emissions, the global pathway, the curve of CO2 emissions has dropped further. But remember this yellow part is not the path that we are currently on. It is the path that we could be on if the net zero policies or ambitions are translated into real world outcomes. Okay, so it's still a very important milestone, because it has ensured that for the first time in history since the dawn of the industrial ages, emissions will actually start to fall here on. And now we will see the role of India in this. So as you will see here, so until this point, the yellow line of announced policy, the announced ambitions or the announced pledges, at that point of time, the world would have still exceeded 2 degrees of global warming by 2050. What India has done is, so India's contribution has ensured that the global emissions by 2050 fall below 20 billion tons per year. So this is a significant announcement by one country. Of course, this gap is not entirely India, it's India and a few other smaller countries, but India is a major kind of contributor to this. We see that for the first time ever, thanks partly to India's announcement, global warming can be limited to less than 2 degrees, to about 1.8 degrees Celsius by 2050. So I think this is a major achievement in terms of India's contribution at the world stage. Moving on, now we talked about what net zero could potentially bring us. But like I said, these net zero policies are not currently the pathway that we're on. We are currently on the stated policies pathway, which is the policies that exist already. So now what I'm going to do is very quickly look at the unique situation that India is in, and compared to that unique situation India in, what we need to do in the future to ensure that our pathway also changes to this net zero future. So currently, over the last few years, India's major success story in energy has been the provision of electricity connections to households. So since the year 2000, India has been adding the equivalent of one Spain, like the entire population of Spain per year, year after year, for the past 20 years, to the point that in the year 2019, finally all households, at least all Pakka households which are registered and census and all of that, all those households have access or at least an electricity connection. Unfortunately, of course, that having a connection does not necessarily mean that everyone actually has 100% supply to electricity. So that's a major challenge. We still have to work on ensuring that all households have 24/7 access to clean, carbon free or low carbon electricity. So that's a major challenge in the future. But the bigger challenge that we have right now is that of clean cooking. To this date, even though government claims that we have provided LPG connections to all households, or most, I think over 80-90% of the households, but despite that, because of affordability reasons, millions of Indians still continue to use biomass alongside. So they may have an LPG connection, but for on day-to-day basis, they're still in villages and so on, they're still continuing to use biomass, which is firewood or gobar or whatever else. That is leading to that is contributing to the air pollution crisis, which I'll get to in the next slide. In India, every year 1.3 million or 13 lakh Indians die prematurely due to air pollutants. This air pollutants come from either indoor sources, including use of firewood for cooking, or outdoor energy sources, which is coal-fired power plants, vehicles, industries, and of course there are non-energy factors like dust and so on. But point is, half of the population of India lives in regions with fewer than 200 clean air days a year. That is, most of us are affected by this problem. It's not a problem of North India alone, but of course, North India, especially the Indo-Gangetic Plain, is the one that is most critically, impacted by the air pollution problem. So as we go on to net zero, we don't have to think of just carbon dioxide. We also have to think of air pollutants. We also have to think of, how can we clear our own air? Now, over the last 20 years, the biggest source of energy demand growth in the world was China, right? Since China's economy was growing the fastest, it's the biggest economy, that was growing at that speed, which meant that China was the biggest source of energy demand growth in the world. Now, this is what the IEA's projections are for the next 20 years. So under the current pathway that we are on, we see that while all other countries and regions are seeing a growth in energy, you see in this map, United States, Europe, and Japan will actually see a reduction in energy use, as a whole, because there are more efficiency and electrification and so on. But other parts of the world, China, Southeast Asia, Africa, South America, will see a growth in energy demand, right? Interestingly, India's growth in energy demand will be higher than any other country in the world over the next 20 years. So India genuinely becomes at the center of the global energy system. India's demand is the demand that drives the global changes in the energy economy, which puts India in a very important position. This is not the India of the past where perhaps we were growing, but not. We are reached a stage where energy demand growth is plateauing in other parts of the world. But in India, it is growing faster than even the whole continent of Africa, the whole region of Southeast Asia, in fact, more than even China. So the question then arises is, if India is the highest contributor to energy demand growth, the question is, where is this growth coming from, right? So what are the centers for demand? So we have identified a few places which are the largest contributors to energy demand growth. First is just urbanization. A lot of people in India talk about India's overall population. Oh, India has over 1 billion people. But in reality, it's not the billion or so people that are the major centers for energy demand. It is actually the urban population that is a bigger contributor to energy demand. And we see that in India's case, in the next 20 years, India is adding the equivalent of one Bangalore per year to its urban population. So it's almost like a new Bangalore is just appearing out of thin air year after year for the next 20 years. And you can imagine that's the amount of energy then that will also be demanded by more people being added and more economic activity happening in urban India. The second bit of the source of growth, and this is related to urbanization, is the demand for floor space or the built spaces. I always tell people who want to kind of imagine how this is. If you look around your house, wherever you're living right now, or your office perhaps, and you see a bunch of buildings, by the year 2040, imagine that would have increased by more than double. So if you have a 10-story building, imagine 2 10-story buildings. If you see a 5-story building, imagine a 10-story building there instead. So point is, imagine double the floor space. That is what will exist by the year 2040. related to that is the steel and cement demand that will arise from that and other economic activity, which will also more than double. In fact, over 60% of the annual production is not even in place today. So that's the kind of growth we're expecting. Air conditioners will be the big one actually. So you see here about, we have about 30 million or so air conditioners in the country today. We expect that to increase to over 630 million air conditioners by the year 2040. So you will see in this next figure as well, air conditioners become the most common appliance in households. So, as households become more prosperous, people buy television, people buy a mobile phone, but the prevalence of air conditioners will be higher than most other appliances. And air conditioners are also the most energy consuming of all the appliances. So you can imagine the load that this puts on the electricity grid. If, as per our calculations, electricity demand from air conditioners alone will be equal to Germany's total electricity consumption today. So the whole German economy, as much as it's consuming, that's the amount that only air conditioners in India will demand by the year 2040. So this is a big source of electricity demand growth coming from India. So we so far talked about the demand side. We talked about buildings. We talked about iron and steel. We talked about even vehicles will double, for example. We talked about air conditioning. But where will this electricity or where will this energy come from? So this is the supply side now. Now we see that over the next 20 years, the biggest change that will happen is the provision of modern renewables. So we are in particular talking about solar and wind in this case. The renewables will have the fastest growth of any other form of energy. And most of this will go into power generation, right? But having said that, because India is still a growing economy, oil, coal, and natural gas are also expected to grow in terms of supply. So we see that in the case of oil, most of the demand will, or most of the supply will go into trucks and cars. But in the case of coal and natural gas, most of the supply will go into industry. So India's industry will grow, and unfortunately at this moment there are no cleaner alternatives. So natural gas and coal will primarily go into industries. Nuclear will also grow, but not by that much. And traditional biomass, this means of course the use of firewood and so on, that will reduce as people move to LPG and other forms of clean cooking. Now we saw in the previous slide that modern renewables have the largest growth over the next 20 years. So what does that mean for India's grid? So now what you're looking at in the figure in front of you is the R2R adjustments in power systems. So in the electricity grid, we see that about 5 to 7% variations happen, fluctuations happen on an R2R basis. These happen because there are fluctuations in the supply, because solar and wind don't have consistent supply. It keeps changing as per the blowing of the winds and availability of the sun and clouds and all of that. And of course, on the demand side, there are air conditioners, which the air conditioning load peaks in the peak of the day when it's the hottest time of the day. So due to these reasons, you will see fluctuations. But interestingly, by the year 2030, as you can see here, this fluctuations will increase to about as much as 20%. This will create a huge requirement for flexibility in India's grids, which would mean that India will have to invest into smarter grids. India will have to invest into newer technologies that help balance the grid. India will have to invest into flexible coal-fired power plants so that the coal-fired power plants can respond to the fluctuations of solar and wind. And India will have to invest heavily into batteries. So batteries, because in India's case, because the fluctuations are almost on a day-to-day or R2R basis, and the best source of storage for short-term fluctuations is actually batteries. So we expect India to become the global leader in battery deployment in the world due to this reason. In other countries, in Europe, for example, the fluctuations exist on a seasonal basis. So you will see that the electricity demand or the energy demand peaks in the winter, but then it falls drastically in the summer. In India's case, it's actually on the same day, that it fluctuates from the morning to the evening. The fluctuation is very high. So that's why batteries work better for a country like India than it does for places like Europe. This as you saw in the two graphs ago, that the oil, coal and natural gas will also continue to, the demand of it will also continue to increase. What we see is, already all of you here are aware that since India imports most of its oil and also parts of it natural gas and coal, India has a huge burden on the current account. So we are actually sending a lot more dollars abroad just to purchase fossil fuels. Unfortunately, under the current pathway that we are on, we see that the value of fossil fuel imports actually triples by the year 2040. So in the next 20 years, we are tripling the amount of money that we are sending outside. So if we wanted to act, if maybe climate change is not your cup of tea, maybe you don't care about sustainability, but even if you care about India's foreign exchange reserves and so on, there's a very good reason to transition away to other forms of energy. One of them is to of course help India in its foreign balances. The impact of this evolution in India's energy system over the next 20 years will mean that in the power sector, the emissions coming from new, you'll see there's new written here in the green curve below. These are the emissions coming from new power generation sources. So this is solar and wind. As you see, they're very little. Most of the emissions are actually coming from the existing coal-fired power plants. So in the case of the power sector, we don't have to worry about the future as much because the future is already looking quite green. It is the existing coal-fired power plants that we have to think about. How do we deal with the emissions from them? But in the case of all other sectors of the economy, industry, transportation, buildings, what we see is that the existing sources emissions will continue to fall because if you purchase a car, the car will be useless after 15 years. Or if you purchase, or if you perhaps manufacture something, those manufacturing plants may need to get new equipment in 10 years later. But it is actually in all these other sectors, it's the new sources of emissions, that is cars that have not yet been manufactured, industrial units that have not yet been constructed, buildings that have not yet been constructed. So the future sources or the future infrastructure that is yet to exist, that is the major source of emissions. And this is a very important point because it shows that as we saw in a few slides ago, if India is the largest source of energy demand growth over the next 20 years, and out of that, if most of the emissions are coming from infrastructure that has not yet been built, that gives us a major opportunity to ensure that our future is better than our past, so that we are today able to make those choices so that tomorrow's generation does not have to suffer. And I think this is a very important point because in other countries, this is not the case. In many other countries, they have to decarbonize existing infrastructure, which is a lot harder to do. It's a lot harder to take existing factories and shut them down. India's case, we don't have to worry as much about what exists today. We have to worry about what is going to come in the future, which is, so if we made the right choices today, we would be able to ensure that we are not locked into fossil fuel or carbon intensive technologies. So this takes me to now the net zero scenario. So far, whatever I talked about is the pathway that we're currently on. The net zero pathway is not what we're currently on. That is a pathway that we should be on. So the line that you see right now, it goes up to 2040. The up till 2020 is the real emissions as exists. After 2020, the blue line is the emissions pathway that we're currently on. So whatever we talked about so far in terms of the rising number of cars and houses and factories, all of that would lead to a growth in emissions from the current level of about 2.5 billion tons per year to about almost close to 4 billion tons by the year 2040 per year. For us to go to a net zero pathway now this is important because so far this is existing policies, now we're talking about an ambition, which could translate into policy in the future. We see that net zero pathway would ensure that by the year 2040, India's emissions would have reduced from even today's levels to go below almost 1.8 billion tons per year. Of course, this is a graph that goes only up till 2040, but you can visualize it. This pathway will take us to net zero by 2070. Okay. So the question is, if we are to go from existing pathway to net zero pathway, then what do we have to do? Like, what additional work do we have to do? What additional investments do we have to make? The first thing we notice is that clean energy investments will have to increase 4 times today's levels, which is a very, very high ask. And it's not something that we have to do in the year 2050 or 60. We have to start doing it from today itself. So by the time we reach 2030, India's clean energy investments should be at least 5 times today's levels. So if we are able to invest more into grids, more into solar, wind, and other forms of clean energy power generation, we can invest more into energy storage solutions, including pumped hydro, including batteries, including all of that, and of course into cleaner mobility. We will ensure that we are able to bend the emission curve from that going up to the one that goes down eventually. Similarly, in the case of vehicles, electric vehicle sales are very low right now in the country. India is in fact lagging behind China, Europe, and other countries. We will have to ensure that by 2040, 100% of all the new cars that are sold are electric. In fact, we should ensure that before even looking at electric vehicles, we make our cities and our towns more walkable friendly. We have better public transport and so on. Similarly, industrial energy efficiency, we have to ensure that we're able to double it. In other words, everything that is manufactured uses half the energy that it uses today. So that's our eventual goal. And finally, low carbon gases. This includes biogases. It also includes low carbon hydrogen, such as blue hydrogen and green hydrogen. From today's 2019 or 2020 levels are very low, almost non-existent. By 2040, we have to ensure that a significant chunk of energy in industries is met by such low carbon gases. Now, here is the implication in terms of power generation. So you can see this is the graph up till 2019, which is the latest data that we have. We see that coal, of course, is the major contributor to power generation in the country. And solar, which is the green line at the bottom, is a very small. It's just only recently it's begun to increase, and it's reached about 5% levels today. By the year 2040, under the current pathway, not the net zero pathway, the current pathway, we see that by the year 2040, already due to existing policies that are in place, by 2040, solar and coal will be generating almost similar amounts of electricity. This is because India has targets of 450 gigawatts of solar, or rather renewables by 2030. India has other policies that are in place, and in general, the prices of solar and wind are dropping. The prices of batteries are dropping. Prices of energy storage is dropping, due to which solar and wind will increase and coal will fall. But this is the current pathway. What we will see next is what happens if we move to a net zero pathway. In the net zero pathway, in fact, coal powered generation falls to about 5%, to where coal is, to where solar is today. That level it will fall in the next 20 years, or that level it will have to fall for us to become a net zero country by 2070. So solar and wind and others will have to increase alongside to ensure that we are basically able to transition away from the most emitting forms of energy. We just take a very brief look at what happens on the industrial side. If you remember in the first graph, we had seen that most emissions come from the power generation side, and second most come from industry. So power generation, we saw in the last graph how solar can replace coal. But in this, we'll talk about industrial emissions. The topmost line is the line that we are on. So this is emissions line. So our emissions will more than double in the next 20 years from the industries side. For India to become net zero by 2070, our emissions will have to peak at some point and then start falling after that. So how do we reduce industrial energy, industrial emissions? So there is no one technology. There's no one obvious way, right? You cannot say that here is the final solution. You put this into place and everything else would be solved. That's not how it works. We have to look at various sources of energy reduction or emissions reduction. This includes firstly material efficiency. In other words, from the demand side, we have to ensure that better designing and more efficient designs will lead to a reduction in demand for iron and steel in the first place, for cement in the first place. So we can make homes that are equally sturdy but using lesser materials. So material efficiency is a very major contributor to it. Secondly is energy efficiency. So being just able to use the same amount of energy more productively. Thirdly, it's fuel switching. So fuel switching includes a few things. Includes, for example, instead of coal DRI in iron production, we can use either electrical, hydrogen alternatives, gas, other forms of fuel switching. Secondly, wherever electricity is used in industries, that electricity can come from direct renewables. So there are different ways to ensure fuel switching takes place. And finally, carbon capture, which is of course just an experimentative technology today, but by the year 2030, we expect that those technologies would have matured. And by the year 2040, carbon capture could have, has a potential to play a significant role in reducing emissions in the industrial sector. So this is just a quick peek into the industrial side. Finally, there are a few conclusions which I will not read out, because we have already kind of discussed these points. So instead of reading out these point by point, all I want to conclude by saying is that the net zero ambition is one that potentially can change everything. It can change the way we manufacture goods, it changes the way we live, it changes the way we travel, it changes our society in very profound ways. So it's actually an economic policy, not just an energy policy. Secondly, at the moment, this net zero by 2070 is just an ambition. It has not really translated into policies just yet. But we are hopeful, even the IIA is working with the government of India, and I'm sure many other civil society organizations will be working with the government of India or with other stakeholders, including the private sector, including state governments, to ensure that in the future, we are actually able to implement some policies that will take India to the net zero trajectory. And finally, that since most emissions and most energy demand comes from infrastructure that has not yet been built, it gives India a unique opportunity to show the world how this can be done, because no other country has done it so far. But India can be the first if it is successfully able to implement this pathway into actual policies and on-ground action. So with that, I will once again thank Chairman Sir and other distinguished guests for hearing me out, for giving me the time to speak with you. If there are any questions, of course, I'm more than happy to respond to your questions.
Hello, Mr. Singh, Mr. Siddharth, I have a question. Like you say, the trend is to India is aspiring to increase the manufacturing activity in the country. And of course, that manufacturing activity will increase by increasing the exports from the country. So the products will be used in other countries, but the emission will be accounted in the name of India. So how do you deal with this issue if the India's economy has to prosper and in activity has to increase manufacturing, but the consumption is happening in other countries? So how do you account for this mechanism then?
Absolutely, sir. I think this is a very significant problem that has kind of been at the heart of the debate of equity and justice. Even China makes the same claims. China is producing goods, but other countries are consuming it, and other countries can show that their emissions have reduced. They've reduced because the factories have actually moved from their country to other countries. So I think firstly, we need to consider how we can account for consumption-based emissions. So, instead of looking at just what the economic activity in a country is, we have to consider what the impact of every country's consumption is. And this includes the trade. This includes international trade, which is often not counted in countries' inventories. But some analysis on that has already been done. And we have found that this is not an IE analysis, it's an analysis done by other organizations. We have seen that there is indeed a 5 or 10% difference in the emissions from the industrial side when you consider consumption based versus production based. But having said that, I think there's a growing recognition that this is a global problem. And if it's a global problem, it needs global solutions, and countries like India, like other countries that are also emerging and that have not historically been contributors to the climate change problem, these countries need financial and other assistance from the already advanced countries who have to take a lead on this, because this is a problem that has been created due to the historical use of fossil fuels and energy sources. So I think, sir, this is indeed a complex problem. It's a problem that is consistently debated at COP and other summits, which of course you're very well aware of. But I think we need a change of mindset as to how we account for this, and therefore how we can collectively ensure that countries like India are get the amount of money they need and the technology that we need to actually on the ground.
Can I have an query?
Yes, sir.
Yeah, I'm Dr. Verma. In fact, I have a very nice and very analytical and explained presentation. Appreciate that. You have not mentioned about the biofuels at all in your presentation. While, as you see, NITI Aayog report in India, which says that by 2025, the ethanol blending in petrol, gasoline is 20%, and beyond that 2030 is 30%. So that will also go to the environmental aspects. This is one. Please, there is another thing which has been bothering me. Perhaps you are the best person to answer that. In fact, we have been, and that is historically I have seen, and therefore I am asking this. See, about 20 years, 15 years back, nobody was talking about the pollution in India, about PM 2.5, about dust, which was a very important factor, which is only, as I have seen, has been recorded only after around 15 years back. We started taking. The similar way, the methane, which is a much more polluter for the environment, that we are not talking about. Even you have also said that you are going to have when you are switching over to power, you are putting about the gas, even for the transportation also, CNG, etc., etc. But the methane, which is going to be, which is much more higher, pollutant and global warming, which we are not considering at all. And I am not seeing in that report. So these are the two things which you can answer and look into. I think I will be grateful. Thank you.
Thank you, sir. I think they're excellent questions, and I'd be more than happy to address both of them. Firstly, sir, you're absolutely correct that biofuels play a very important role in the decarbonization of both the transport sector as well as other places where they will be used. Yes, I did not include it in this presentation because actually with time limit and so on, I had to consider where I can save time. But in the India Energy Outlook report, we have actually looked at biofuels into further depth and detail. In fact, a recent report that came out from the IEA just less than a month ago showed that India is actually going to become the world's biggest market for biofuels within the next 10 years or so. So this is because, as you have correctly mentioned, of course, India has an ambition. India has an ambition, as you say, to increase blending into petrol, and in fact, even diesel, biodiesel will have. We expect a 20-fold rise in the biofuel market in the country. Like India's biofuel market will have a 20-fold rise over the next decade. So I think this is a very important point, and I thank you for bringing it up, because indeed, what we see is that on the four-wheelers and two-wheeler side, of course, there's a global push towards electrification. So we're seeing electric vehicles come out, especially electric two-wheelers. These days, you will find it more and more common. They have green number plates, so we can easily identify these electric vehicles. But in the case of trucks, in the case of bigger vehicles, we see that more than 50% of emission growth in the future comes from these big vehicles, which have no such electrification or other such initiatives happening, at least in India's case. In such places, the use of biodiesel and the use of other biofuels will prove to be very, very important in the decarbonization process. But having said that, I will also add that in India's case, the biofuels experiment has always trailed the policy ambition. So when the government wanted 5%, this is a few years ago, when it wanted 5%, we actually just achieved 1.7% blending or 2% blending. And this is a consistent issue that we're having because of the seasonality issues of the supply of the biofuel itself. You know, there are different ways that we actually extract the biofuel, and there are different supply chain problems as well. There are storage problems. If you want the supply to be consistent through the year, you need certain types of storage and certain other characteristics which unfortunately don't exist. So for those reasons and the seasonality issues, it has not been as successful. But having said that, I agree with you, sir, that it's a very important source of decarbonization in the future. Secondly, you talked about methane. Just to add here that methane is a very important greenhouse gas or a very potent greenhouse gas. So it actually it has more global warming potential in the short run than even carbon dioxide. We don't consider it a pollutant. We consider it a climate like a greenhouse. So in the sense that if it is breathed by us, perhaps our lungs will not be as affected as a PM 2.5, but at least on the side of the climate change problem, it is even more important. So I fully take your point that so on this front, actually, the IIA has very recent, because unlike other things, methane can leak from various places. Methane can leak from the wells itself, from coal-fired, from coal mines. It can leak from the actual methane beds. It leaks from the pipelines. It leaks from industries, and then finally, once it's burnt from the cars and the vehicles, then there is also pollutants from the other side. So there are the different places where it is a problem. All these years, we were actually not able to figure out where methane is coming from. Fortunately, in recent years, thanks to cheap satellite technologies, we have finally been able to map the world and figure out that there are certain spots that we never even imagined. We never thought about that those places are the places where methane would be coming from, but they turned out to be some of the biggest. There are spots in China, in Russia, which are so far away from any place that we would consider to be polluting, but those are the places where methane is really leaking out. So there is something called the Global Methane Initiative, and at Glasgow it was constituted. So the idea is to stop unabated methane emissions by 2030 globally. Now this is an ambition. I don't know how realistic we'll be in actually implementing it, but for the first time, this has been it has had global recognition. So let's have some hope that that countries will actually put in policies. So far, it's only an ambition. The problem with many of these things are talk is easy, action is action is what is very hard. So the leaders have spoken, but now it really comes down to how can we act on this.
Okay, Siddharth, thank you for, I think other people can also ask some other questions. Just a minute, Akhilesh, just a minute. I have, Dr. Verma mentioned about methane, and so is the NOx, which is also a greenhouse gas. And both methane and NOx, agriculture is one of the sectors which is responsible for major ones. And as you mentioned about the methane initiative, there is also initiative about sustainable nitrogen management when I'm talking of NOx. And nitrogen management, when I say including agriculture, and of course, industry and transport, this thing, everything, everywhere this NOx emission is there. So I thought when we talk of zero emission or these gases, two gases are also equally important, where there is already a resolution in the United Nations Environment Program in 2020, March 2020, for sustainable nitrogen management, because nitrogen is the new carbon, which is proving to be even more important than the carbon emission. Yeah, Akhilesh, please go ahead.
No, I'm Sambi. I just want to ask one question. The last person asked that biofuels will help in decarbonization of but my point is ethanol also has carbon atoms. So it will also contribute to carbon dioxide. So in case of our country, when we mix ethanol with petrol or diesel, we are reducing the amount of import of oil from other countries, and that way we are reducing the dollar outflow. So that is the main reason why we should encourage biofuels, and not that for decarbonization. Any
Yeah,
comment?
driving force, he says, is because of we want to reduce our petrol import bill.
Yes, sir. So, firstly, absolutely correct. I think we need to, also think about the impacts on the import bill, and also point taken. So even if we can reduce, for example, 10% of the demand of crude oil thanks to this, I think that's a major achievement. But having said that, again, this is a little contentious. You're absolutely correct that it has carbon and therefore there is emissions. But I think the way the accounting is done is that in the case of bio, because the trees itself, like because of the short time scale of the whole cycle, the trees and the other plants where this may be taken from may have been only planted a few years ago. So the cycle of carbon use is shorter, and therefore it's not a case of historical emissions from millions of years ago being unlocked through the use of fossil fuels, which is why we think of it as something that is actually
Green energy. Yeah, you're right. You're right. Dr. Sami is accounted that biomass, when you grow, it already, absorbs carbon dioxide, and whatever is emitted when you use it, that is still remains net decarbonization. That is how accounting is done. That's what Siddharth is mentioning. Yes.
Yes, sir. So, Mr. Akhilesh Kumar had to speak, but sir, you're muted, sir. If you can unmute yourself, please.
Okay.
Yes.
Can you hear me?
Yes, sir.
You have talked about trajectories of various emission streams. Is there going to be a platform which will monitor the parameters of the trajectories and various emission streams? And is there any Government of India plan in this direction?
Yes, sir. In fact, this has been one of the major achievements from the latest Glasgow climate change summit, because since the Paris Agreement was signed, the question always was that every country can claim whatever they want. Who's keeping a tab? How do we know? What are the parameters by which, and what are the definitions by which we can actually check and keep a track on each other? How do we police each other? So firstly, for the first time, that agreement was reached in Glasgow. So now I think by 2 years from now, there will be a mechanism in place from which annual accounting will take place. Secondly, India already does some accounting through its biennial update report, or BUR, which is sent to the UNFCCC. So actually, sir, if you Google UNFCCC BUR India on Google, if you put this term, you will find the latest report. But these are only voluntary at the moment. So every country can have different methodologies. 2 years from now, it will be a common methodology that all countries have to use, and we can audit each other then. There'll be mechanisms in it for every country to monitor each other.
Fine.
Okay.
I have another question.
Excuse. No. Dhiraj, please, just a minute. Dhiraj, you have a question? You have 2-3 hands.
Yeah. I have only one small question for that.
Yeah.
That's all. And after that, nothing. You have talked about global warming less than 2 degrees with regard to India. This is linked to what level of CO2? Presently, we are at 412. And at that point of time, when you claim that 2 degrees reduction will be approached, what will be the CO2 level in India that time?
Sir, I don't have the answer to this question immediately, but I will quickly ask my team in Paris who actually works on this, and I will get back to you in the comments.
Okay, thank you.
Thank you.
Okay, Dhiraj, please.
Yeah, so first of all, excellent talk. My 2 small questions. So one is, you talk about the trucks pollution. So I just want to know, Government of India is now promoting transport through trains through waterways. So like we have DFC, dedicated freight corridor. Will it help reduce the pollution to that extent as we are thinking the trucks will do? Means can they substantially reduce the truck load? And the second thing is about the flexibility of grid you talk about. So can having a localized power production based on, let's say, small diesel generator based on local biomass fuel or something, and the small grid, local and smart grid, would it help to reduce the flexibility or the fluctuation in the grid on hourly basis in India? Thanks.
Yes, sir. So thank you, sir, for the questions. I think firstly, as far as the trucks, as far as the freight transport sector goes, we are actually currently doing a study on exactly this question. It's being done between another think tank called CEW and IIA together. And we are trying to figure out how the multimodal shifts, as you say, from trucks to railways and waterways, how to what percentage or what a specific number can be put onto the savings that I made. Firstly, in theory, yes, of course, as more cleaner forms of transport, there will be reduction in emissions. In fact, we have seen globally, there's only one country where this has actually happened to that level. There is a similar proposal in Europe, in Australia and other advanced countries where they wanted to move away from trucks to trains and other things, but only the US has succeeded in it. But the problem is that even so, in a country like India, because the volume of transport will increase so much, even if we railways, the growth in trucks will still happen. So it's not like in India's case, the trucks use is being reduced. Maybe it may be, instead of increasing by 10%, it'll increase by 5%, or by 7%, but that's still a growth. So while yes, waterways and the dedicated freight corridors are great initiatives, but by itself they will not have the desired impact that we would like. The second question is on the flexibility of the grids and how maybe macro mini grids and other localized power generation. I think on the other hand, India has actually trying to do the exact opposite, which is to create a wider and more connected grid, so that we are able to use inter-regional changes to balance the grid. So it's of course, I mean, localized grids are very important. I'm not an electrical engineer myself, but from my understanding of the IIA team that actually works on it, they do help in certain situations. In a country like India, you also want to make use of the fact that maybe in Rajasthan and Gujarat, the solar generation is very high, whereas Tamil Nadu, the wind generation is high. How can we bring both of them together to provide stability in the grid in Madhya Pradesh? That's the kind of question that is being I think tackled with. But on the other hand, as far as storage goes, I fully agree with you, sir. I think storage should be localized. So any form of either batteries or pumped hydro or whatever else, that is something that needs to be done at a more localized level, because you don't want those electrons to be traveling across the lengths of the country, but because of efficiency reasons and all of that. But I feel that it's something that we need a mix of both approaches.
Yeah, Suruchi Kumari, there is one somebody is Suruchi. Suruchi, are you there?
Anil Razdan here, sir. If you
okay, Verma
Yes.
Sahab,
Hello.
okay, Suruchi is there, right? Please go ahead.
Yes, sir. Sir, my name is Ruchi Kumari. I have one question about, sir, as you said, electric mobility to cut down on a vehicle population and reduce dependence on the crude oil importance. But now these days, we faced with the dual challenges of manufacturing of lithium-ion batteries and the subsequent environment threat posed by the battery wastage. So how we can manage, how India will manage for this wastage and lithium and battery manufacturing, how it is possible?
Yes, thank you for the question. So very quickly, I think in general, through human history, as we have noticed, we don't really solve problems. We replace one problem with another problem. So when we first when coal first came into the picture, we actually helped address deforestation that was happening due to the use of wood, and coal helped solve an environmental problem, so to speak. But we replaced one with another, and now coal is seen to be a part of the problem due to air pollution reasons and climate change and so on. Similarly, vehicles itself, when cars first came about, they solved the problem of in the Western countries, since horses were used, the horse shit on the streets used to lead to many diseases. So in many ways, cars help solve that problem. Now, of course, emissions from cars are a problem itself. You're absolutely correct. I think if we are not able to have appropriate policies in place to unlock the value of the lithium batteries once the car is done with, that itself could lead to different forms of pollution. I think as far as today is concerned, 2022, climate change is a bigger problem than soil pollution, at least in the conception of the leaders and scientists and so on. So I think that's the reason why that has gained more prominence. But I fully agree with you that we need appropriate policy value so that we are able to appropriately either recycle or ensure that dispose of properly any used batteries. If we don't do that, it will lead to problems in the future, including pollution of the underwater streams and a lot of other things. As far as where the lithium will come from,
sorry, there is a related question by one Mr. Rajiv Sachdeva. Which technology will be dominant by 2040, whether hydrogen storage or battery storage?
So IIA's analysis on this is that there is no one technology that wins through the marketplace. The question is storage for what cause? So what IIA's analysis shows is that for short-term storage, battery storage is going to win at the marketplace because of its nature and the falling cost. Whereas for long-term storage in countries, in the European countries, for example, where they need to, where the excess electricity that is generated through renewables can be used to create hydrogen that helps meet demands in the winter, after 4 months. In those conditions, it's hydrogen that will be helpful. In India's case, battery storage, where we have intraday fluctuations in supply and demand, in such cases, battery storage is like to be more dominant. Similarly, in the case of transport for small vehicles, two-wheelers and four-wheelers, we are already seeing that battery-based technologies are winning at the marketplace. Perhaps hydrogen can have an impact for very long duration trucks. So not even short trucks, but the trucks in, for example, Australia and other places that traverse the length of the country. So in such places, hydrogen may win out.
Okay. Mr. Verma, please. There is one raised hand.
Yes, could I?
Yeah, please.
I have a few comments and some information I could actually discuss in your presentation at length, and we will go on for hours, but we don't have the time. One comment, of course, is you would agree with me that energy is governed by the laws of nature, called the laws of thermodynamics, which are eternal and inviolable. Any energy in the solution which we come with will have to be within the ambit of the laws of thermodynamics, which are laws of nature. That's one comment. The other comment is, or the piece of information, I really don't know if you have come across the book, The World of Energy, Engine of Life, and her tagline is understanding that there is no free lunch, caught between a rock and a hard place. I mean, perhaps it'll interest you if you read that book. It covers the entire energy space, and it discusses things from the energy fundamental point of view and raises many of the things which you have raised in your presentation. The last comment which I would like to make is, nature has provided an automatic cleanup mechanism only for the carbon footprint by way of the CO2 cycle. There is no automatic cleanup mechanism for nuclear waste, electronic waste, plastic waste, any other man-made waste. And lastly, if you could share your email address with me, I would be very happy to interact with you and send you an email.
Sure, sir. Thank you so much for your comments. I will leave my email in the chat box for you and anyone else who may want to reach out. But just to say, it's s_singh@outlook.com. But I will share it nonetheless in the chat box. And point taken, sir. I think I will definitely look up this book, and also point well taken on the CO2 cycle. I think the only point I'd like to add here is that the CO2 cycle only works when it's in balance. Unfortunately, it's way out of balance now, where we're putting in way more CO2 than we're able to extract back and put it back into the cycle, into the
I
earth.
react to what you just said.
Yeah.
In this book, there's a chapter which is titled I think the exact title is "Fossil Fuel Bugbear of Climate Change" or something like that.
Right, sir.
I mean, if you check it out, the CO2 concentration in the atmosphere almost 400 million years ago, 500 million years ago, was 18 times that what exists now. And also about 300 million years ago and today, the CO2 levels are almost the same. And if you look at the temperature graph there really is no correlation between the CO2 concentration in the atmosphere with the temperature. Now, there are many aspects of how we estimate the temperature of the Earth. That's why I said I would love to interact with you on email. I mean, there's a hell of a lot which we can discuss.
Okay.
Thank you.
Okay, thank you. Thank you very much. I think it's about time.
Mr. Anil Rajan had a question.
So if there is time permitting, maybe just Siddharth.
Please go ahead.
Thank you, sir. Siddharth, it's an excellent presentation by you, and I'm so glad that the IEA is partnering with India in such a major way. And but having tracked this controversy or this debate for almost 30 years now, I have a point which I think you must start adding on, which we developing countries have. And that is, you talk of aggregate emissions. If you're talking of something globally and something which is of global concern, you should talk of per capita emissions. Secondly, you see, if there is a technology issue, again, if it's a global problem, there are two issues for developing countries. One is cheaper credit. Number two is technology transfer. Unless we talk of these things, I don't think the darker continents, as we call them sometimes, will really be able to participate in the spirit in which the IEA and other global community is going about it. And the last point is about blending. Ethanol blending. We talk of ethanol blending. I worked in the petroleum ministry also. And you see, ethanol in India is from sugarcane, not from other cellulosic matter. Brazil is a totally different ballgame. You need water for sugarcane. India is extremely severely water handicapped, and there could be extreme water scarcity. So when we talk of ethanol blending, we have to be careful not only of the food chain, but also of the water chain. Yes, foreign exchange outgo is a major issue and stability of sugar prices, but then water, I think, is a major problem. But all in all, I think an excellent analysis and great. I'm so happy that the IEA India bond is growing, and I'm sure it will grow stronger.
Thank you very much, sir. And just to add that, the reason why IEA's relationship with India is so strong is precisely because of Sir Mr. Anil Razdan, who has, led this kind of, or rather been a very good friend of the IEA and our Executive Director, Dr. Fatih Birol. So thank you personally for everything that you have done to help grow this relationship. And on your point, sir, just very quick response to it. I fully agree with you, and I think it's something that we have been very careful to present. I mean, in today's presentation, yes, I did talk about overarching like aggregate emissions, but that was to show where India is headed as a country. But when it comes to issues of what we call justice or equity and so on, it is definitely per capita. In fact, in our own report, we have highlighted time and again how India's emissions and energy use is actually a very small fraction of even the global averages. So if really action has to be taken, it has to be led by countries that have been historical emitters and historical contributors to the problem. And therefore, in fact, one of our recent studies was precisely on the availability of clean energy financing for emerging economies and emerging markets such as India. So I think the idea is that if we are unable to put money and, as you say, technology transfer on the table, it will be very unrealistic to expect a country like India, which has its own development priorities, to accomplish any form of energy transition. For us, energy transition actually means providing electricity regardless of where it comes from, providing cooking energy, providing other forms of energy to people who need it in an affordable manner. So that is the kind of revolution that we are seeking to build. But at the global level, they also talk about decarbonization. So point well taken. So I think that is something that we must continuously remind ourselves to not lose track of the needs of India and Indians.
Thank you.
Okay. Thank you, sir, for your comments. Biofuels have always been contentious issue. And you have made a very good point of that we have been saying that both rice and sugarcane are water intensive, and you are seeing what is happening in the agriculture intensive areas of Northwest India. So that's a very valid point. Other than diverting the food crops to for biofuels, this is additional important point. Thank you, Siddharth Singh, for not only making a very interesting presentation, but generating quite a bit of interest, lot of interest, because this is the topic of the day, where we are, grappling with various issues of when we talk of climate change, or to how to help avoid the temperature rise. There are conflicting things, many things, and this is, of course, as has been made, rich versus poor countries and financing, etc., which point has been, something was agreed upon in Paris Agreement, which has not been, has taken shape. So thank you once again for this thing, and we will now proceed with our next step or next program, which is for scholarships by the Indian Institute of Chemical Engineers Northern Region. I invite Dr. Swami to make the announcements. Dr. Swami, please.
Hello, please allow me to say just one ad. Hello.
Okay, please.
Thank you.
Okay.
Thank you for allowing. In fact, what Mr. Razdan has said, he was additional secretary when I was head of R&D of Indian Oil Corporation. And what point we have started, I think what I wanted to say, we in India, we followed the example of Brazil, and accordingly go for sugarcane. But now with the mandate of NITI Aayog, 20 and 30% is there, it cannot be met. So one is the second generation ethanol, which is basically based on the biomass, but today it is costly. So that is the reason it's not. But there is another way where the Americans have made a lot of progress, that was based on the corn. Corn requires 1/4 of the water consumption compared to the sugarcane. This is one. Second thing, this right now we are importing a lot of crude, and America is growing that is called a non-edible yellow dented corn. Now the same can be imported initially at the same duty as the crude oil, and at the same time Indian farmers are bidding for that sort of corn which is non-edible. So this way, this will solve the problem of one is the food versus the thing, and secondly, if you are using a corn, in that case the protein part is totally extracted. The oil, which is called corn oil, is totally extracted. So what is remained? Only the starch, which is converted to ethanol. So this is a one-way win-win situation, which unfortunately I think now Government of India, Ministry of Petroleum, is taken up, but not to that extent. So these are the things which I would like to put in and should be taken into account for the so far as what we are currently environmental concern. And Mr. Singh, what I have understood, the overall exercise of whatever is about the global warming, and global warming where the methane is much more 20 times higher than that of the carbon dioxide. So it has to be taken, what you said is to be taken care. Thanks for allowing me. Thank you.
Thank you, sir. Thank you, sir. Points well noted. Thank you.
Thank you, Dr. Verma. Yeah, Luthra sir, we can go ahead to the next program.
Yes, yes. First, I must thank Siddharth Singh ji for excellent presentation. It has generated a lot of interest among the members, and we appreciate you have spared valuable time to share your thoughts with our group. Thank you very much once again.
Thank you, sir.
Now, may I request Dr. Sambi? Hello, Professor Sambi?
Yes, I'm
Please.
listening.
Please, now you start the proceeding of the presentation of scholarship to the students. We have just shared the list of the students which you may announce.
Okay, good morning, everybody. We distribute Golden Jubilee scholarships every year, and we have allotted 20 scholarships to BTech students. 15 scholarships to BTech students and 5 scholarships to MTech students. And there is one more scholarship by a private NEAS. So in all, 21 scholarships we distribute. Now this year we got about 30 applications, 23 for BTech students and 7 for MTech students. And we have certain criteria for distributing these scholarships, which is given in this presentation also. So on the basis of that criteria, we have selected 15 plus 1 BTech students and 5 MTech students. Now the list of selected students of BTech is as follows: Miss Divya Singh, UIET, CSJM University Kanpur. Then second is Miss Bushra Mukhtumi, NIT Srinagar. Third, Miss Niharika Agarwal, Malviya National Institute of Technology, Jaipur. Fourth, Miss Neha Sharma, UIET, CSJM University Kanpur. Mr. Sagar Nain, D-Crust Murthal. Muhammad Kaif, UIET, CSJM University Kanpur. Mr. Utkarsh Tripathi, UIET, CSJM University Kanpur. Shivam Sharma, D-Crust Murthal. Chaudhary Jyoti Nain Lal, NIT Srinagar. Abdul Qadir, D-Crust Murthal. Shakshi S, NIT Srinagar. Abhishek Dhiman, D-Crust Murthal. Aditya Gupta, D-Crust Murthal. Pankaj Kumar, IIT Delhi. Fahim Hamid, NIT Srinagar. Priyanshu, D-Crust Murthal. He was awarded a scholarship of 20,000 rupees by GJ Samaj Kalyan Nyas scholarship, but other students got scholarship raise, that is 25,000 each. Now the MTech students, Ms. Aarti, IIT Delhi.
Sambi Sahib, it is 30,000, not 25,000.
Okay, sorry. If it is 30, it is 30,000 rupees. And second is Satyam Yadav, IIT Delhi. Mr. Manish D-Crust Murthal. Mr. Ganesh L. Naik, IIT Delhi. Mr. Virender D-Crust Murthal. So these, this raise in amount of scholarship was done this year. It was from 20 to 30,000 rupees. And okay, now I hand it over to Mr. Luthra to take further action. These scholarships certificates will be issued and the checks will also be issued. And since we are not holding any physical meeting, so these will be sent to the respective head of the departments for further distribution to students. Thank you.
Thank you, Dr. Sambi, for announcing the awards of scholarship to the student. I may add, there might be some delay in sending the checks and certificates because of the lockdown situation in Delhi. So since we are not working from the office, so we have to get it completed the moment the office starts working. So please rest assured, your certificates and the checks will be sent very shortly. Thank you very much, Sami Saab.
Okay.
And now, may I request Mr. C.P. Srivastava, Honorary Secretary, IIChE NRC, to give vote of thanks to the speaker.
Thank you, Luthra ji. Chairman, sir, and fellow participants. It was nice to have today's conference. At the outset, the chairman mentioned the celebration of the foundation of IIChE NRC, which was in November, December 1960. So I take this opportunity to express our gratitude to the founders of the IIChE NRC and subsequent office bearers, executive committees, and the fellow members who have contributed a lot to take an IIChE NRC forward and bring it to the present level. I also wish that today on the Foundation Day, the present office bearers, executive committees, and the members will continue the same spirit to build up the NRC in more and more progressive. I also wish for the future of the IIChE NRC to be great. I take the opportunity to congratulate all the students who have been given the Golden Jubilee scholarships and wish them a very happy studies and the future ahead. The letter by Siddharth Singh was really very relevant and important in the present text of the world's energy requirements increasing day by day and the side effects affecting the climate change and the pollution levels. So building a net zero future is the challenge for the whole world, and IEA, which has been doing a great work, and their association with India should grow more and more. So he addressed a lot of areas in a short time and covered many of the things and answered very, very prominent or very important questions and the queries raised by the participants. I also thank the participants, especially who raised the questions and the queries, which gave an opportunity to Siddharth Singh and others to know something more and more related to the subject. So thank you all. And we conclude today's session with the permission of the chairman, sir. Thank you.
I just like to mention that IIChE is celebrating the Platinum Jubilee year this year or 2022. So this is just for the information. There's quite a number of programs are being, will be organized by the different chapters of IIChE, and IIChE and NRC also planning, at least given the circumstances, to organize the program, which the topic which we have already selected, green hydrogen and green ammonia. We have the outline of the program, so we will go ahead as probably in June, when it suits I try to organize it in IIT, and the timing will be suitable for IIT at that time. And I request Professor Saroha and Srivastava Sahab to work on that so that we can, issue at least an initial announcement or brochure for the program. So that's about it. We will organize the next lecture in the middle of February. And so Shambang is here. Is somebody was ready? You mentioned that Mr. Narang was ready.
Yeah, Mr. Narang wants to do it in April. In February, we can work with somebody else. So if office community, I can always help talk to people and come back.
Okay, now February we, as has been suggested also, probably you only suggested that this nano urea.
Yeah.
So we can do that in February. I've already talked to the person. So that will be nano fertilizers. The IIFCO is not only making nano urea, but they are also making some nano micronutrients and now nano DAP also. So we will do that in February.
I'll ask a question here to Dr. Siddharth, Mr. Siddharth Singh. Now, when we are replacing urea with nano urea and reduce the consumption by half, 50%, how would it be accounted in terms of our net zero contribution?
I don't think that has been taken into account. We are just I'm just
asking this question. I mean, hypothetically, how would it be accounted for?
So basically, with any emission reductions, we compare the current pathway with what could potentially, with what the delta is. So it could be, I mean, I'm not an expert on this particular aspect, so I cannot say what would happen in this specific, because there is actually a very lengthy laid down procedure as to what aspects of technology lead to what emissions and where we can show the savings. Okay. But having said that, in general, we look at the current pathway with the potential change.
You mean to say?
Shambang, I'll answer you in more detail. First of all, you are using the fossil fuels to make urea. So you will save that fossil fuel. So that much CO2 emission you will save. Whatever your CO2 emission is there per ton urea, those numbers are available now with the best technology or best available technology or practical available technology. Second aspect is that you reduce the nitrogen emission, which I mentioned, that nitrogen has become the new carbon. So we are mentioning the active nitrogen. This is not nitrogen molecule. It's active nitrogen, which is great greenhouse gas. So on these two aspects, one is on manufacturing, other on use of urea. The accounting can be done. Whatever more efficiency we achieve, nitrogen use efficiency. This is one of the factors in sustainable nitrogen management. So how much nitrogen use efficiency we are improving, and that means we are reducing the urea production. So production and use efficiency, both accounting can be done.
Good. Thank you.
Thank you. Thank you once again, everyone.
Thanks.
And we end the program today, or today's program.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you very much for joining the program. Thank you.
Luthra-ji,
Can
you pass this information that Professor V.K. Srivastava has been awarded this lifetime achievement?
Oh, yes.
This was circulated also, and my congratulations to Srivastava sahab.
We congratulate Srivastava sahab for well-deserved recognition. We had circulated to all the members also. Srivastava is there?
Yeah, he's very much there. He's He's on
Okay.
mute, so you have to unmute.
So what we are saying is that congratulations once again for this well-deserved recognition.
From my side also.
Congratulations, Professor Srivastav. This is Verma. Yours is muted, so you can't hear. And thanks for a very nice program to IIChE. I think I really enjoyed attending this program. Thank you. And thanks also to Mr. Luthra for reminding several times. I think it's really great. Great job he's doing. Thank you.
So Dr. Verma, keep attending programs. You will get good programs in future also.
Yeah, sure, Venkat. Very, very nice. I think things are moving forward.